Alrighty, so you guys have made it to the second half of the course. Congratulations. We're on the downhill side now. So today, we're going to talk about VPN fundamentals. As we move forward, our learning objectives this week are describe the fundamental functions of virtual private networks, otherwise known as VPNs, common VPN technologies, and the elements of VPN implementation and management. The key concepts are the VPN essentials, the VPN models and architecture necessary for implementation, the differences between VPN transport and tunnel modes, VPN connection encryption, and VPN authorization and authentication. So you may ask yourself, what exactly is a VPN? Well, a VPN is a virtual private network. It's a mechanism to establish a remote secure connection across an intermediate network. Oftentimes, it's the internet, for lack of better things. But there are other instances where you can set up a VPN, and these can be over insecure lines like the telephone company or the telcos, otherwise known as. So if you're going across intermediate networks, and let's say you have a dedicated line to somebody else where it's a direct connection, but it still is routed through the phone company's networks. There is a possibility that if you do not encrypt while in transit, this traffic could be intercepted by someone else, and therefore your data could be compromised while en route from point A to point B across, what you might assume is a private network. So, in other words, a VPN is something where it allows remote access, remote control, and highly secure communications within a private network. A VPN also employs encryption and authentication to provide confidentiality, integrity, and privacy protection for a network communication to occur. So, a lot of people have a concept of what exactly does a VPN do here. The way I like to think of it is like a car carrier. You know, as cars are produced at the factory, you know, the plant or something like that, they get loaded on to a car carrier. The car carrier, is basically an 18 wheeler that has double decker that carries cars that otherwise would be able to drive that same road. Uh, they drive those cars to a dealership where they are unloaded and they go on to their destination, which is usually a parking spot on the lot for them to be sold. But the art of transporting those from the factory to a automobile dealer is the same concept of a VPN. A packet gets encapsulated into another carrier that is then used to transport the packet safely between 2 points without those being exposed to the dangers like on the road. So, kind of like that. Another one would be like a automobile ferry. If you ever go between, mainland and an island or something, and you're driving your car, instead of using a bridge, a lot of times they would have these automobile ferries. So you would just drive on the ferry, and then when it gets to the other side, you drive off the ferry. And that transport is like that, for instance. So if you can picture it that way, that's a good way to picture it. So there are different types of VPN connections. One is the trusted VPN, and this is where the primary organization owns all of the network infrastructure equipment. So this can be between, let's say, different locations within an environment, maybe between two data centers on the same campus. They can set up a line that's maybe exposed to the elements outside. Across that line, they can establish an IPsec tunnel so that nobody might, climb the telephone pole on their property and kind of listen in. So this would be an area where, you have a trusted VPN. A lot of times you'll see trusted VPNs between different zones within a company. Let's say you have an instance where privacy needs to be maintained uh, between different elements within the corporation. A secure transfer of data. This would be used, an IPsec can be used for that within the same data center or within a same corporate environment. Now, these are usually a dedicated set of channels that are used across these telco connections. These provide physical isolation even on third-party equipment, hence it's considered privately maintained. Now, the encryption ensures privacy even over those public networks, such as the internet. Now, a hybrid VPN establishes secure VPN over trusted VPN connections. So that's where you have a hybrid where you have a VPN within another VPN, basically. All right, here's an example of a secure VPN where this is a virtual private network. Maybe this could be done with basic encryption here. You may have a secure VPN with a trusted VPN between two sites, maybe between uh, two remote access servers here that establish some kind of a IPsec VPN or a Meet Me VPN or one of these other types of VPNs out there, where data is transferred between these remote locations on that trusted VPN that is vertical in the picture here to the secure LAN on the lower side of the picture and back up to the secure VPN rather in the upside of the picture, on the upper side of the picture. Now, a hybrid consists of trusted VPNs on a secure VPN segment within a trusted VPN. So as you see here, they're basically trusted VPNs between everything. So these all have to set up point-to-point VPN connections. And these are all enabled so that there's encryption enabled between all different sites. Now, what is remote access and how is that different from remote control? Remote access allows a link across the network resources using a wide area network to connect to a distant network. So a lot of times you connect into work, or when the olden days, people would use a dial-up modem to connect in to the internet. Nowadays, everyone's always pretty much connected to the internet. But you can see there's things out there like ways to connect in to your network to maybe access your corporate email or access items on the LAN that you need to get resources from, or your internal servers to download files or connect to stuff out there. So these are ways that allow remote workers who are out in the field to connect into the corporate network, and it kind of makes them feel that they're locally on that network. So the client system can technically perform all the same tasks as if they were on the same network. Now, remote control is kind of like where somebody does a system and they use a technology like a HVD or HVA where they can go in there and remotely control a remote server. A lot of times, like terminal services and Citrix, ICA, these are protocols that were used to do remote control. You were connecting to a device, but that device was there, and you just initiated commands to that remote system to allow it to connect. So, network administrators impose restrictions on which networks and services a remote VPN can and cannot use. So let's keep that in mind. All right, what is a virtual private network continued again? So let's now consider a LAN and remote client that each have a connection to the internet. Now, pretend you're at home and you have a work. Both of them have their own independent ISPs and their own connections. Uh, they're controlled by different folks, and You control your internet connection because you pay for it out of your own pocket, or maybe your parents pay for it, who knows. And so these are there. So now we have the LAN connection is usually a permanent dedicated connection supporting both inbound and outbound activities to the internet. This is more on the corporate side, but we're now seeing this more and more with dedicated home networks that are like on cable modems, DSL, and fiber connections to our homes. So now we have LAN connections that are permanently and dedicated connected to both support inbound and outbound activities to the internet. Now, the remote client can have dedicated or non-dedicated access to the internet. You can disconnect or connect. So the new network connection is established from the remote client to the LAN across an intermediate network. And remember, intermediate network is something like the internet. And that new network connection is the VPN. So it's our virtual private network. So let's take a look at how that will look like in pictures. On the right-hand side, we have the remote client. In the center, we have the big bad internet. And on the left-hand side, we have the corporate LAN. So the connection is there between that, and we see how these are normally connected. And on the next one, we established a remote access connection into that corporate LAN where we can get traffic to and from, and that long line between the corporate LAN and the remote client, that is a VPN there. All right, everybody, that's amazing. All right, now let's move on. So, secure VPN concerns. There's concerns about a VPN. Well, maybe. So all VPN traffic must be authenticated and encrypted. So remember, what is authentication? Authentication means proving who you are. So any kind of VPN without authentication is not private. And any VPN without encryption is considered insecure. Now there are VPNs that do not use encryption. In the old days, these were called encapsulating VPNs. These encapsulating VPNs were like from Cisco L2P and Microsoft's point-to-point tunneling protocol, PPTP. These did encapsulation without encryption, but they did the authentication aspect of it. So we have that part of it there, but not complete. It was insecure VPN. Now, all VPN endpoints must abide by the same computer or same parameters and algorithms. So they all have to negotiate on security, algorithms, and RAS connections. And RAS means remote access service connections. Now, each VPN tunnel must have a corresponding encryption key that sets to a security exchange encrypted content. Now, a lot of you have already taken cryptography, maybe, or some secure networking, and this is your PKI stuff. So you have a public and private key that are exchanged. The public keys are exchanged, and each side encrypts with the other side's public key, and they decrypt it with their own private key as the traffic is sent to them. So they all have to negotiate on that kind of stuff there. Now, the same goes for a security policy should govern all endpoints. So you can have different security policies, but a security policy needs to govern the endpoints whether they're on the LAN or on remote. And they should have some of the same commonalities there, which have the same, profile and posture settings that they have. Proper encryption protocols must ensure that there are no third party can affect the security of the VPN. So this means there's something called a shim. That's a piece of software that inserts itself in the IP stack that can take out data and read it unencrypted before it becomes data in use. So these are a lot of times viruses and other things like that that have been known to do this. Now, many operating systems now have made their stacks a little bit harder to do that for and shim into it. And they have modified the Endless layer so that these shims can no longer actually intercept that information as it's in transit. Weak encryption makes a secure VPN vulnerable to attacks, so don't use any deprecated encryption algorithms like triple DES or any of those other ones that are old and not used anymore. Try and stick with those AES 256 ones out there. All right, so what other trusted VPN concerns? Um, the provider's ability to limit and control access to the VPN content. So if you get on just VPN and you're able to access everything, there is no discretionary access controls out there that prevent you from accessing other things. Um, just as you are in a LAN, you may not have access to certain things based on uh, your role or who you are or what permissions you have. So these also must be enforced on VPN connections. Okay. Only the trusted VPN providers should be able to modify the channels or pathways of the VPN. So here we have it. So only the VPN, whoever if it's your corporate VPN, they should be able to do that and control who gets in and out of that path. And only the VPN provider, whoever is the VPN host that you're trying to connect into, has the ability to, or should have the ability and power to add, remove, or change data in the trusted channel. Uh, Addressing and routing is performed within the trusted VPN must be defined before the VPN goes offline, or online rather. So as you're connecting and establishing, a route table is exchanged in there, which gives the client the local routes. So it sends route information to the client and tells it what networks it's able to connect to via that VPN. And so those are added to a route table with the VPN interface as the gateway. So that's how that works there. Services are predefined in the SLA, service level agreement. Those are always fun to read. I always tell stories about certain service level agreements for software and other things. There's one company out there that said whoever sends this phrase to this email will receive a $250 check, and they buried it somewhere in their really long service level agreement. And it took them like 3 years before somebody actually caught that and read the service level agreement to claim their like $250 prize. So, yeah, that's kind of a fun fact if you ever want to read service level agreements or you plan to go to law school. So, these are always fun to do. All right, so what is a VPN continued more? Okay, tunneling protocols. They encase or encapsulate that original network protocol so that it can traverse the intermediate network. So, like I said, it fits it. Another packet gets fit into another packet. And the dominant forms of secure VPNs use IPsec or SSL/TLS as the tunneling and encapsulation protocol. So here we see the IPsec protocol and the SSH and the SSL secure socket layer. SSL has kind of been deprecated. Point-to-point tunneling protocol has also been deprecated. L2TP has been pretty much deprecated, although you will see it in a few things still. And TLS is kind of the current one out there. TLS 1.2 and 1.3 are your current standards. You see a lot of stuff in SSH, things like SFTP and SCP happen through a secure shell. Those are over port 22. IPsec has a number of other things that occur through it, and it's a very extensible protocol for that. All right, and we're going to talk about that in a second. So here's a little eye chart for you. And if you look in your notes, you can see the common VPN ports and protocols. And so, we can see like all the different ones, SSTP, L2TP, IPsec, L2TP with IPsec. And this is the one you'll still see around a little bit. OpenVPN, you'll still see that one around, and IKE V2, and that's your more common ones out there. So what are the benefits of deploying a VPN? The first one is productivity. So granting access and resources in a timely, efficient manner assists completion of work. So we have productivity increases. This came in real big handy during the pandemic when a lot of people had to work remotely. So This worked out well. It helped increase productivity and help maintain that business continuity for a lot of folks. Uh, Remote access can happen from a number of different devices. So you can connect to it from laptops, tablets, mobile phones. Depends on where you're at. Go through your internet cafe, i.e., a Starbucks type of connection. Uh, Hotel networks, random Wi-Fi spots, like if you're in the airport or on an airplane or something like that, you can set these and connect to them. Um, Now, it also helps reduce your risk by insecure connections. So, establishing a VPN helps reduce those risks out there from happening. All right, we also have cost savings because telecommuters and traveling workers save a lot on long distance charges where they have to dial in and transfer data. Nowadays, they can just VPN in using their wherever they're at, using that kind of stuff. This was more of a big problem when I was about your age, where we'd have to dial in and spend a lot of money. I'd have whenever I was traveling for work, I would have maybe like a hotel bill of about $60 or $70 from just dialing up, using the phones to connect out. Um, we have businesses that need local internet links for VPN rather than having a dedicated lease line. So let's say you have a remote office. Those remote offices can have a VPN established to them using whatever normal internet connection they normally have. And there's just really no overhead to that other than their internet connection and the ability to configure it. So let's look at a corporate network uses dedicated lease line versus a VPN across the internet. On the left-hand side, each of these buildings has to establish a direct telco connection to other networks there for redundancy and direct connectivity. Now, considering through the internet a VPN network, all of these can kind of still virtually create that weird pentagram shaped connection over there, but it kind of looks more like a virtual private network where they can connect to each other using what looks like a centralized internet service. Technically, they're establishing VPN connections to each other, but they all have a common connection to the internet, and they don't have to have additional leased lines over a dedicated mesh network. So, what are the benefits of deploying a VPN again? Reduced equipment cost, unlimited geographic connectivity. If you're here in Texas, you may be in South America, you may be in California, you may be in Europe or Asia or even Antarctica. All these places have internet connectivity, and you can establish a VPN connection from any of those. Also, you have increased versatility from wherever your worker may be. You can still have them connect to you and collaborate with you uh, on a network so corporates can take advantage of remote workers if needed. The VPN also helps improve privacy and confidentiality due to that encryption aspect. There's verified transmission integrity because these occur over TCP, Transmission Control Protocol, which allows for that session to be set up, and if a packet gets dropped, it can get retransmitted. And again, fully scalable global infrastructure and architecture, so it doesn't matter where you're at around the world. VPNs can be deployed really quickly, so you have rapid deployment options. They offer flexible integration with existing networks and technologies. It's a faster return on investment than with traditional WAN things because once you set up your internet connection and you buy your VPN equipment, um, once it's paid for, it's paid for, and from then on, you could just keep going with it. So there's just not a lot of other stuff out there for you in that aspect other than just, the basics for that. So instead of lease lines where you have to keep paying monthly, you're just paying your internet connection and all that. Um, Reduce dependence on long distance carrier solutions. So in the olden days, we used to have these bank modems set up for people who didn't have direct internet connections or VPNs. They would have to dial in, and if all the modems were in use, they'd have to get that busy signal, and they'd have to keep retrying. It's a pain. But now with VPNs, there's really not a limit on how many people can use that situation or that solution for you. Uh, and we have the reduced burden on the ISP because, they're just routing packets. They don't care what's in it. So what are the limitations of VPN? Well, it does not ensure quality of service. So you can't say I have the fastest internet connectivity, but your VPN may actually be a little bit slower because of other things out there that, kind of give it some limitations. There can also be internet latency, packets that get dropped every now and then. Let's see what else. Strong encryption's not used. People may be able to hack into it maybe and crack it. There could be vulnerabilities at the endpoints because, these endpoints are appliances that are made with software, and all software can and probably does have some vulnerability somewhere in it. And then if the VPN isn't working, you can't just put your hands on it because it's remote and it's not easy to get to those systems while they are in remote locations. So in the olden days, I would actually see people who would have to get on planes and fly somewhere to get to those systems. So, all right, so now we're going to talk about what are effective VPN policies. So we're going to look at the aspects of designing and planning a VPN policy, but not quite limited to. We're considering the benefits and drawbacks of whether you're going to use a hardware solution or software solution, uh, imposing stringent multi-factor authentication, where you have multiple elements that that validate who you are on all VPN connections. Let me just say, yes, you should. You really should implement multi-factor authentication. Okay. Um, Implementing strong access controls, authorization, and put those restrictions on all VPN connections. Yes, you should. Defining how the VPN will be managed through which interfaces and by whom. So this is documenting who your administrators are and who will administer and manage these VPN connections and make sure it's documented well. You're going to be exploring the complexities of patch management over VPN. So are you going to be able to issue patches to someone if they're not, let's say they connect in, but they don't have that quote security posture to where they're all patched up and safe to be on your network. Uh, there's solutions out there that can do that. So yes, you should do that. You want to define the mechanisms of how you're going to provide remote technical support for the VPN telecommuters, and you're going to be enabling detailed auditing on all activities that come through VPN. So logging, which you should be logging everything anyway. You should have some kind of a log showing who connects where and when and who accesses what. Um, you're going to define distinct qualifications for granting access to the VPN. So what qualifies the user to do this? Are you going to allow, you know, maintenance workers to get VPN access maybe, or, stuff like that? Maybe not. Uh, you're going to allow, people who work on, IT security VPN access, probably. You're going to allow people who work on like, uh, maybe processing loans or processing documents or accounting VPN access, probably. So then you're going to have to look and see who should get VPN access and how to define what they are, and then you also have to make sure that everyone is properly trained for that VPN access to happen. So here we have three deployment models. The first one is the edge router. The next one is the corporate firewall. And then we have dedicated VPN appliances. Now, edge routers, you don't see them as much anymore, but these are just devices that are the ones that allow you to connect to the internet. A lot of people will throw a VPN module on one of these, and so this is between you and the internet. Also, you can have corporate firewalls that allow that corporate connection to it, and there's a firewall thing. And then you can have your dedicated VPN appliances. Now, the architectures can go from remote access, where multiple users can dial in and connect in, like, if you connect into your work, that's a remote access connection. Between different sites, like we call it site to site, this is the VPN is underlined and it's not known to your users. Um, a lot of companies will deploy certain equipment to certain people so that, whenever they bring their corporate device on their home network, it's automatically connected to a special device that establishes a site-to-site VPN. And, they don't have to understand it, how it works or anything like that. It's automatically connected. And then we have the host-to-host or peer-to-peer VPN connections. Now, these are established, just to have a point-to-point security between stuff. A lot of times these can be done through TLS or SSH. So if you need to manage something and you SSH and open a command prompt to something on a remote system, you say, I'm doing an SSH to it, or you want to do a secure copy to something. Those are an example of host-to-host connections. Now we have the VPN architectures, which are also known as these. This is an example of the host-to-site VPN, where you have the VPN links between the clients that go across the internet, and they connect into a system there, and they are on the LAN just that way. Next, we have the site to site. So we have two different sites here at the bottom. If you look at those pictures there, they are connected through the internet through a VPN link, and these are known as LAN to LAN VPNs or WAN VPNs. And they're basically connections between the LANs. The users on each of these devices have no clue that there's a VPN that connects the two sites together. It's an expensive mechanism to create a single distributed LAN, and site-to-site VPN happens with a lot of remote mobile users, but mobile users usually use a host-to-site VPN. And a combination of site-to-site VPN concept with remote access VPNs is where you have them all using that same VPN device, whether they're remote as a single user or LAN to LAN. Now, a VPN model here shows a LAN with those, VPN links. You have the LAN to LAN, and then you have the individual links in there. And that's kind of what your hybrid model looks like, where a lot of places you'll see that deployed. Um, Now here's your VPN, host to host. It's also client server, remote to office, remote to home VPN. It's basically a direct thing between one system and another. Operates over a private network or a public network, it doesn't matter. Over a public network, provides security from the public. Over a private network, just an additional security for those who have prying eyes where they shouldn't be. All right, so we have extranet access. Yay. This positions the VPN tunnel as an endpoint at or inside the perimeter of an extranet. Now, this serves as the pathway or the gateway for business partners, distributors, or others to gain access to corporate resources without exposing their traffic to the internet or granting others unnecessary access to private LAN. So these are specific portals. You make a connection to it, and it is a site just for a partner VPN or something like that. You'll see these like, um, for instance, like at my company, we have a private connection to Staples. So if I need to order, a new stapler from Staples, I can connect in there through that corporate portal. It allows me to connect in, and I can securely order a new stapler that will be delivered to me. So that's an example of an extranet for one of our partners. The VPN is linked to the extranet as opposed to a demilitarized zone. So it's really set to a private set of web servers usually, and it doesn't allow the public to access that kind of stuff. It provides greater security to remote entities, and it grants the remote entity secure communication without having a VPN termination point. Okay. Now we're going to talk about the tunnel versus transport mode. A tunnel mode encryption is where it protects the original IP and header in the payload. So this takes whatever your IP address is, basically it grabs the whole packet and stuffs it inside the data payload of another packet. The way I like to consider this is the truck carrier. You know, that is there. So it's loaded onto the back of a truck. You know, it's there. Uh, the encrypted packet becomes the payload of the new IP packet with the new IP header, i.e., like the cab of the truck and all the cars loaded in the trailer. That's the payload. This ensures that the identities of the original endpoints and the communication are kept confidential. So imagine that truck carrier has a big tarp over it so nobody sees what's inside of it. And these are commonly used by VPNs linking network sites together, providing remote access. Now let's talk about transport mode encryption. This only protects the IP packet header's payload. The way I like to say, this is like a tow truck. You know, the front wheels are lifted up, but the back wheels are still on the road, kind of like that. So the payload is encrypted, basically, uh, but only the original packet payload is there. So you see a couple wheels on the road, but the rest of it's kind of protected. Uh, the encrypted payload retains the original IP header, so there's like the tires that are being towed. So that's the original IP header kind of thing, like that. If you can picture that in your mind, and it's being towed by a tow truck or something like that, and you see that being pulled that way. So only the payload's encrypted, so only the contents of what's inside that car are protected with the lock doors and stuff. The rest of the packet can be seen and it's visible. So we have that there. All right, so now we can see that the relationship between encryption and VPNs, the secure VPN traffic is encrypted. Trusted VPNs may or may not use encryption, but they probably should nowadays. Cryptography. This is the art and science of changing information so it's not easily recognized or understood by unauthorized third parties. Okay, so this is like the spy stuff here. This is the code breakers, you know. So for everything from the Caesar cipher to AES encryption, there's different ways to just how convert readable information into something that is unknown without having a way to decipher it. So cryptography includes methodologies of encryption and decryption, and modern cryptography is now based on mathematical algorithms like AES or RSA and a few other things like that. So let's look at encryption. It's a process of converting original usable data, called plain text, into a chaotic form called ciphertext. Decryption is the reversing of that ciphertext back into plain text. And the algorithm is just a set of rules and procedures in a mathematical nature that define how the encryption and decryption process operate. Encryption algorithms always use a key. The encryption key is always unique and a secret number that controls the encryption and decryption, otherwise known as a public key and a private key, that perform the process within the algorithm. The bit length of the algorithm's key defines the algorithm's key space and the level of encryption. So weak keys are shorter than 128 bits. Strong keys are 128 to 256 bits, and very strong keys are greater than 256 bits. So let's talk about symmetric cryptography. Ooh, fun stuff now. These are based on algorithms that use a single shared key. The synonym for symmetric is same. That same key is used to encrypt and decrypt data. And the key must be shared with all communication partners within that same session. So this is very fast compared to asymmetric cryptography. These are examples: DES, triple DES, AES, CAST, RC4, RC5, RC6, RC7, IDEA, Twofish, and Blowfish. These are all symmetric cryptography. All right, now here's symmetric cryptography process. We have our famous Alice and Bob. So Alice and Bob want to communicate and encrypt stuff. So what happens is Bob and Alice exchange the keys. Bob then encrypts in step 2 there, encrypts it with that key, and in step 3 he sends it to Alice. In step 4, Alice unlocks that key using the key that they exchanged. So this is kind of like public key, PKI, where each of them exchange a key to do that. Now, asymmetric cryptography, this is based on key pairs or special mathematical mechanism. Asymmetric pair key cryptography uses key pairs known as public key cryptography. This is synonym for asymmetric, means different. So the key pair consists of a private key and a public key. The private key is kept secure and private at all times. It's probably best where it's stored on a hardware security module or HSM. The public key is put out for open access for everyone to use. So it is very slow in comparison to symmetric key cryptography, and it's best suited for identity proofing and key exchange. So let's look at how this works. We have Bob and Alice again, and they're going to use PKI here. So Bob wants to send something to Alice. So Bob uses Alice's public key, and then, Bob then encrypts it with Alice's public key and sends it to Alice. Alice then uses her private key because Bob used Alice's public key to encrypt the traffic, the message, and then Alice can use her private key to decrypt that traffic. Okay, very simple there. So once it's encrypted, nobody else can decrypt it but Alice. Okay. Well, we're also talking about hashing now. Hashing is like a digital signature. It kind of proves the identity of the sender. It's not encryption. It does not provide confidentiality protection, and it is improved through the addition of hashing. And hashing is a one-way cipher. So let's talk about the signature process. Okay, so we have here Alice wants to send something to Bob. Okay, so Alice hashes her stuff to show it's there, and she uses it to Bob, and she sends it to Bob. Bob looks at it, decrypts it. Alice encrypted it with Bob's public key, and then Bob looks at it and looks at the Alice's public key and does a hashing on it to see if it comes out to be the same. But Bob decrypted it with the Bob's private key because Alice encrypted it with Bob's public key. So that's how a asymmetric cryptography happens with a signature. So we have it hashed, and it's usually a message digest that's usually at the bottom of a message. So she encrypts the message digest one way with a hash using like a public key, and uh, Bob can also hash that message with a public key and compare them and make sure that they're the same message. Now, here's a crazy algorithm, just what exactly I explained there. And so we have the hashing function and the asymmetric encryption process of a digital signature with the hashing. So as we see there, the hash is created and it's 101.001.101. And as it goes through all these steps to 1, 2, 3, it's added onto the encryption because Alice is sending stuff to Bob. She encrypted with Bob's public key. Bob then gets it sent to him, and then he looks at the hashing message and hashes it with the hash, same hash that they have, and goes to step 6. They validate it and unencrypt it with the hashing with the Alice's public key, and so they validate that the 101.001.101 is the same on both sides. So hashing is a cryptographic function that takes the input of a file or message and creates a fixed length output. Basically, that 101.001.101 or whatever it was. The input can be of any size, but the output always is going to end up being a fixed length based on the hashing algorithm used. Uh, this could be something like SHA or something like that. Uh, it does not modify or alter the original data in any way, but rather uses the original data set to generate a hash value as a new item. This verifies the integrity based on the complex mathematical functions used in the hashing algorithm. Hashing is a one-way function. All right, so this just identifies that, hey, if I hash it using the same message that you hashed it with, using that same algorithm, our results are going to, if I get that same message and you send me that message as hashed, I compare the two and it's there and they're both the same. Uh, you will often see that in emails that use PGP, pretty good privacy, where it says, hey, nothing has been altered by this. Here's the hash function. And, you can go over here and look at the digest on my website for that and validate that this has not been changed. It also happens you see a lot of hashing occur in files that are downloaded from the internet. So VPNs often employ hashing as part of digital signatures as a method to confirm that the transmitted data does have integrity. So the overall cryptographic process of establishing a VPN connection can get quite complex here. So we start with step 1 here, and Bob's, gets, uses Alex's public key. He has his private key there, creates the message, sends it to step 2 with the hashing, gets sent over to Alice, step 4, step 3, step 4, step 6, all that get employed here, where the key is used to encrypt it. That's also sent. So as you see here, in step 7, we have an encryption methodology. We also have the hash value that's sent underneath it. And we also have a key pair that might be established that is used for the encryption, which tells you which hash it is used as that's negotiated. So we know what key is being used, and that key is changed. So as we look here, we go on to step 8, where Alice takes that key and does the encryption and sends it back over through there, and It gets using Bob's public key to create that hash value and is sent to Bob. All right, now we have Alice and Bob. They've negotiated that hash and now they can send data back and forth. That's encrypted and they can always validate it using the hashed values. So they compare the pre and post hash values. The hash value is the same, is retained integrity. Bob's identity is validated, and the encryption enables symmetric key and subsequent messages from Bob to Alice and from Alice to Bob to be established. Once that VPN is staged, a session key exists at both endpoints, and during the shared session, they can encrypt and decrypt traffic to each other, knowing that they got good. Okay, so here we're going to talk about digital certificates. This is where a public key and a private key pair are digitally signed by a trusted third party. These can be like Entrust, GoDaddy, DigiCert, or whatever. These are trusted third party certificate associates. Now, the CA first verifies the identity of the person or company, then crafts and creates and issues a digital certificate for them. The public-private key, you're going to see a lot of these certificates when you make HTTPS connections to a system. So whenever you look up these things, this is where you are like saying going to https://cougarweb.colin.edu. Within that connection, you're going to see all the CA path, but you're going to be using that certificate, that's the public key, to encrypt any traffic to that website. Okay? And so you're going to be able to have that traffic encrypted that way, and you're going to see all that traffic to and from that will be used that way. So next we're going to talk about VPN authentication. VPN authentication is a process of confirming the identity of the user. It is highly important VPNs do this because VPNs allow external entities to connect to and interact with the private network or system. Now, VPN authenticates on two levels, the connectivity and the user. So this means a VPN can be established based on the system that is connecting to it along with the user itself. So these are two things that we need to keep in mind where that VPN connection is established and connection on. Now, what is VPN authorization? Authorization is controlling what the users are allowed to do and what they are allowed, or what are they not allowed to do, rather. It's also known as access control. These are clearly defined by policies that establish activities that will and will not be supported for VPN connections. So these are things we need to keep in mind. So, am I able to download all the private, HR data through a VPN connection? Probably not. So these are some things you don't want to do, or anything that's proprietary. They may not allow you to have access to it if you're connected to it via a VPN. The initial concern that defining users that allowed to establish a VPN credential. So if VPN connectivity is neither essential nor conducive to a worker's assigned tasks and responsibility, the user should not be allowed to open or connect via VPN to your network. So you don't want the lunch lady to be able to VPN outside of work to your network and access the plans to the new rocket to the sun or whatever. Also, access should also be restricted to resources across the VPN, even for authorized users. So you want to kind of restrict people what they can and cannot act where they're not on the LAN, just, as you would. So in summary, a virtual private network has a lot of essentials that cover it. We talked about VPN models and architecture necessary for that implementation. We have VPN transport and tunnel modes, connection encryption, and VPN authentication and authorization, with a little crypto thrown in. Well, I hope you've enjoyed this session. And I'll talk to you later in chapter 10. We'll rehash a lot of the same stuff again.